So we are going to keep working through this chapter. We're finally moving into the next section. We've been on 5.2 for a week, I think, maybe over a week. We're going to look at some formulas involving cosine today. So my first question is this true? Cosine of A plus B, is that the same as cosine A plus cosine B? I mean, it's like distributive property. Does that work here? And so to figure that out, let's try an A and a B. Let's say I did 30 degrees plus 60 degrees. What is 30 plus 60? What is the cosine of 90? So think about your hand trick. If you fold in your 90, cosine is the square root of the bottom over 2. So square root of 0 over 2 would be 0. Right, let's try the other side. What happens if I did the cosine of each one? The cosine of 30 degrees plus the cosine of 60. So cosine of 30, fold in your 30, cosine's the bottom, so that would be radical 3 over 2. 60 is radical 1 over 2 is 1/2. Is radical 3 plus plus 1 over 2 the same as 0? No. So these are not equal. That means when we are dealing with trig functions, if you have an argument with multiple terms, you can't just distribute. We have to think of a different way for going through that. So there are actually formulas for this. If you go to your little book of formulas, we have a sum and difference formulas tab. And we are going to have a total of 6 formulas that we will write down on here. Today we are only going to do the formulas for cosine. So make sure, go ahead and write these 2 formulas down. Make sure you get your signs written correctly. So that's what we're practicing today. I want to find the exact value for these. All right, it's been a little bit since we've done this exact value stuff, but that's like our unit circle things. And when I said exact value, that meant with radicals, so not the decimal that your calculator is going to give you. Now, if I looked at this, 75 degrees, that's not one I have on my hand trick. So I can't just do it that easily. So think about the angles we know. 0, 30, 45, 60, 90. Is there a way you could get 75 by adding or subtracting 2 of those angles? What could you do? Let's see. Cosine of 45 degrees plus 30 degrees. So then we have the cosine of 2 things added together. So you go to your formulas, that's the cosine of A plus B. So the formula says you do cosine of the first, cosine of the second, minus sine of the first, sine of the second. And we're just using that formula. The A is 45 degrees and the B is 30 degrees. So now we plug in our values. The cosine of 45 degrees is what? Cosine of 30 degrees. Minus the sine of 45 degrees. Radical 2 over 2. The sine of 30 degrees is 1/2. When you multiply, radical 2 times radical 3 is radical 6. 2 times 2 is 4. Radical 2 times 1 is radical 2. 2 times 2 is 4. So you could answer it like that. Since they have a common denominator, you could make a single fraction, but radical 6 and radical 2, those are not like terms, so you can't actually combine them. Let's do a quick check to see if our answer is right. Grab a calculator. The original was in degrees, so flip it into degree mode. So if we type in the cosine of 75 degrees, we get this decimal. Then let's type in our answer. We have the square root of 6 minus the square root of 2, all divided by 4. And you see we get the same decimal. Okay, so we have the exact value, the radical form, but you could use that calculator to double check and make sure your values worked. Any questions there? Let's try another. It is harder when things are in radians to figure out what adds or subtract. It's just hard for us to think about. So my recommendation is if I give you something in radians, let's just convert it into degrees. We know to do that, we multiply by 180 over pi. So those pi's drop. So I have 17 times 180 divided by 12. 255 degrees. I don't know 255. So I need to think of two angles we know that would add or subtract to 255. Now obviously 30, 60, 45, 90, that's not going to work. So remember we have the whole unit circle. If you have a copy of your unit circle, you might want to pull that out so you can look at it. We need any two angles on that circle that would either add or subtract to give us 255. Page 111 in the textbook has a picture as well. So we need two angles off that circle that would add or subtract to 255. Can you come up with 245? Okay. That's not the only combination. So you can get there different ways. That's why work is so important. When you are doing this, make sure you write the steps so I know what you are looking at. You could have also done like 315 minus 60. Whether you do the plus or the minus is what determines which of these formulas you use. Okay, if I did 315 minus 60, it doesn't mean my b is negative. It means I'm using the subtraction formula. And the only difference is the sign in between these. So you just pick the formula based on whether you did addition or subtraction. So that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. All right, let's talk about 2tan for a second. What quadrant is that? Reference angle 2tan minus 180 is 30. In quadrant 3, is cosine positive or negative? Negative. And then the cosine of 30 degrees? 3 over 2. Cosine of 45, that's just quadrant 1, so that's just radical 2 over 2. Minus sine of 2tan. So in quadrant 3, sine is negative. Sine of 30 degrees is 1/2. Sine of 45 is radical 2 over 2. So if I multiply And multiply the tops, multiply the bottoms. So we get negative radical 6 over 4 minus negative radical 2 over 4. Minus and negative would make plus, so you could leave them separate since they do have a common denominator. If you wanted, you could put them in a fraction like this. Either way is fine. Is that one okay? Let's try another. All right. What's different about this one? Yeah, I gave you the right-hand side of the equation. So look at your formulas. We have cosine times cosine plus sine times sine. Which formula is this? It's the cosine of A minus B formula. So my A is 173 degrees minus B is 83 degrees. 173 minus 83 is 90, and cosine of 90 is 0. So you can use the formula either way. Is that okay? Let's try a couple proofs related to this. So we don't want our proof skills to go away. We'll keep having those. All right, which side would you box in? All right. Okay, so on the left, this is the cosine of A plus B. So we can use the formula. Cosine A, cosine B, minus sine A, sine B. Okay, 2 pi is the same as 0. What is the cosine of 2 pi, or the cosine of 0? Okay, fold in your 0. Square root of the bottom over 2, so square root of 4 over 2 is 1. Minus sine x times sine of 2 pi, or sine of 0. So if you fold in your 0, sine is the square root of the top over 2. So that's 0. So I get cosine x minus 0, which is cosine x. Okay, so if I were to combine this, cosine, cosine minus sine, sine, which formula is this? So my A would be the 3x plus B would be my 2x So that just gives us cosine 5x. Last problem. Another proof. Which side would you box in? Do we have a formula for secant of a minus b? No. But we know secant is the same as 1 over cosine. So we're going to do the cosine of a minus b on the bottom. So that's cosine of a, cosine b, sine a, sine b. 3 pi over 2. And that's right here. Think about your unit circle. That's the point 0, negative 1. So cosine of 3 pi over 2 is 0 times cosine x. Sine of 3 pi over 2 is negative 1 times sine x. I get 1 over 0 minus sine x, or 1 over negative sine x. And what's 1 over sine? So this is negative cosecant x. Any questions for me? I'm going to give you guys time to work.